Okay, the AI revolution is here. We all see it. It's building a whole new world. But there's a huge problem hiding in plain sight. AI needs an absolutely insane amount of power. And, well, our grid just can't handle it. So where are we going to find a clean, reliable, and just massive new source of energy? Let's dig into this, because the solution might be this unlikely hero that's literally been right under our feet this whole time. Everything in this new digital world, it's all built from code. Ones and zeros. It feels so abstract, right? Almost weightless. But here's the thing. That code has a very real, very physical cost. It doesn't just float around in the cloud. It runs on seriously powerful physical machines. And this is where it all lives. Rows upon rows of servers packed into these massive buildings called data centers. These places are the real physical heart of AI, and they are incredibly hungry for one thing: power. An almost unimaginable amount of it. Which really brings us to the central question we have to ask ourselves. What happens when our digital dreams start demanding more juice than our physical world can actually supply? When the engine of AI needs way more fuel than our current system can possibly provide? And look, this isn't some problem for our grandkids to figure out. It's happening right now. The sheer scale of AI's energy appetite is, well, it's staggering. And it's creating a major, major bottleneck for the entire industry. So, take a look at this. What's wild about this slide is just how uncertain everything is. The projections for how much power data centers will need by 2030 are all over the map. Some folks predict a huge increase, others predict a truly astronomical one. The only thing everybody agrees on? The line is going up, and it's going up fast. So let's try to make that number real. If we take the average of all those predictions, the US is going to need an extra 41 gigawatts of power capacity by 2030. To put that in perspective, that's a 13% jump over the entire country's power demand today, just for AI. That is a massive new load to dump on a system that's already creaking at the seams. And yeah, that's the other half of this whole puzzle. It's not just about making more power. It's about getting that power where it needs to go. And our grid, the whole circulatory system for our energy, it just wasn't built for this kind of pressure. This right here, this slide, just nails the core problem. Big tech can throw up a massive, power-guzzling data center in, 2 or 3 years? But building the big power lines needed to connect it, that can take a decade, sometimes 2. We're talking about a fundamental mismatch in speed that's causing a huge traffic jam. So what makes data centers so tough on the grid? Well, first, the power they need is incredibly concentrated. A single campus that Microsoft and OpenAI have planned would use more power than 3 million homes. Think about that. Second, there's absolutely zero flexibility. They have to run 24/7, period. You can't just ask them to power down during a heat wave. And like we just saw, they get built at a pace the utility industry just can't keep up with. And the result is basically gridlock. You've got to imagine a massive traffic jam, but for electrons. There are literally long lines of projects waiting years just to get plugged into the grid. This isn't just some minor inconvenience. It's a real threat to the whole pace of the AI revolution and to US tech leadership. So, if the grid can't handle it, where do we find all this new power? Well, the answer might come from a pretty unlikely hero, a clean, constant source of energy that you can build exactly where you need it. We're talking about geothermal. Now, you've probably heard of geothermal energy, right? The traditional kind taps into the natural heat from the Earth's core, usually in places like Iceland with hot springs and geysers, to create steam and spin a turbine. It's powerful and it's incredibly consistent. But here's the absolute game changer. Engineered geothermal systems, or EGS. This is a breakthrough that uses really advanced drilling techniques, a lot of them borrowed from the oil and gas industry actually, to create our own geothermal reservoirs deep inside hot rock. The revolutionary part? It means we could potentially unlock geothermal power almost anywhere on the planet. And for AI, the advantages are just huge. First, unlike solar or wind, it's what's called baseload power. That means it's on 24/7, running over 90% of the time. That is a perfect match for a data center. Plus, if you build it right on site, you're way less dependent on that strained grid. And with this new EGS tech, it's scalable and it's clean. But wait, there's more. Geothermal has another trick up its sleeve, a kind of secret weapon that makes it a perfect match for data centers. See, it's not just about providing power, it's also about getting rid of heat. Just look at this. A massive 35% of a data center's energy use isn't even for the computing. It's just for cooling. All that energy is spent on one thing, keeping all those servers from overheating. It's a huge, constant drain.
And this is where geothermal is just so cool, literally. The same system that brings up heat from the earth to generate electricity can also be used to run a super efficient cooling system. It's a two-for-one deal. You get power and cooling all from the same hole in the ground.
So what does that mean for the bottom line? Well, it's huge. The analysis here shows that for a big 1 gigawatt data center, using this integrated geothermal cooling could save around $107 million every single year. That is a massive leg up on the competition.
Okay, this all sounds great in theory, but can we actually pull it off? Is it really affordable? Let's take a look at the actual path to making this whole thing a reality.
You know, the numbers are actually surprisingly good. This chart shows something called the levelized cost of energy. It's just a standard way to compare the costs of different power sources. And right now, with a little help from tax credits, a new geothermal project can make power for about $88 a megawatt hour. That's already competitive with a brand new natural gas plant. So how do we get this done and get it done fast? Well, we turn to an industry that's already the world's expert at drilling deep into the earth. The International Energy Agency points out that over 75% of the know-how needed for next-gen geothermal, well, it's stuff the oil and gas sector does in its sleep. Their expertise is the key to getting this off the ground and bringing costs down. So here's the roadmap. First, we leverage all that existing expertise. Then we invest in the first wave of projects to get the ball rolling. As we build more, we get better, we innovate, and that's how we drive down costs. The goal is to get the price down to around $50 or $60 per megawatt hour, which would make geothermal cheaper than just about any new natural gas plant you could build. And you gotta understand, this is so much bigger than just a debate about a cool new energy source. Solving this power problem is absolutely fundamental to staying ahead in the AI race. And in the 21st century, that is directly tied to our economic competitiveness and, frankly, our national security. So as we're racing to build this incredible future of intelligence, we're staring down this immense energy challenge. We've looked up to the sun, we've looked to the wind, we've looked to the atom. But what if the most powerful, the most reliable, and maybe the most elegant solution has been here all along, just waiting for us in the heat deep beneath the ground?